Let's talk about one of the most important, but maybe one of the most overlooked, safety features inside your home: electrical grounding. Seriously, it's this invisible system working silently in the background, and you really need to understand how it keeps you safe. It all starts with a pretty simple but kind of startling question.
Yeah, I know, it's a wild question, isn't it? You use stuff like this every single day without even thinking about it. But under the right or, the wrong set of circumstances, any appliance with a metal case, whether it's your kettle, a toaster, even the microwave, could pose a lethal threat if something goes wrong on the inside. Let's dig into why that is.
So the whole problem really starts with a hidden danger. It's this invisible risk that's just sitting there inside the very devices we use all the time.
Okay, so normally an electrical circuit is pretty straightforward. You've got electricity flowing from the wall outlet through the live wire into the kettle's heating element. It does its job, boils the water, and then it flows right back out through the neutral wire. It's just a perfect, self-contained loop, and as long as everything stays inside that loop, totally safe.
But this is where things get dangerous. See, over time, wires can get worn out. They can fray. Now, if that live wire inside happens to touch the metal casing of the kettle, well, the entire metal body, the part you actually touch, suddenly becomes energized. We call it going live. It is now officially part of the electrical circuit, and it's just waiting for a path to the ground.
And that brings us to a fundamental law of electricity. You have to remember this. It is always, and I mean always, trying to get back to the earth, back to the ground. And it's lazy. It will always take the easiest path it can possibly find.
And that right there, that gets to the absolute core of the problem. When that electrical fault has nowhere safe to go, it basically becomes a trap, just waiting for a path to open up. And tragically, the next person who touches that appliance, they become the path.
So when you reach out and touch that now live kettle, your body, which is standing on the ground, becomes the path of least resistance. You literally become a human wire. That electricity surges through you to complete its journey to the earth, and in the process, it delivers a massive and potentially fatal electric shock. This really shows you exactly why that's so terrible. Your body, well, it has a pretty high electrical resistance, but it's not nearly high enough to stop a dangerous current. A dedicated copper earth wire, on the other hand, has an extremely low resistance. So if electricity has a choice, it's always going to take the superhighway, that's the copper wire, instead of the bumpy, dangerous country road that is, well, you.
So how do we make sure electricity always takes that safe path? Well, we build one for it. Let's meet the two heroes that make this whole safety system work: the earth wire and its lightning-fast partner.
First up, the earth wire itself. This is the reason you see 3 prongs on the plugs of your metal appliances. That third pin? That's the connection to this dedicated emergency exit for electricity. It physically connects the metal shell of your kettle or toaster all the way back to a metal rod that's literally buried in the earth outside your house, creating this permanent, super low-resistance escape route.
But you know what? The earth wire doesn't work alone. It's got a high-tech partner, and this is it: a residual current device, or RCD. Now, if you're in North America, you probably call it a ground fault circuit interrupter, or a GFCI. Think of it this way. If the earth wire is the emergency exit, the RCD is the hypersensitive, lightning-fast security guard standing right by the door.
The RCD's job is actually pretty simple, but it's absolutely brilliant. It is constantly measuring the current flowing out on the live wire and comparing it to the current flowing back on the neutral wire. In a perfect world, those two should be perfectly balanced. But if even a tiny little bit of that current goes missing, which means it has leaked out somewhere, like say down an earth wire, the RCD knows instantly that something is very wrong.
And when I say tiny, I mean tiny. RCDs that are designed to protect people can detect a leak as small as 30 milliamps. That is just 30 thousandths of an amp. It's a minuscule amount of current, but it's more than enough to be dangerous to the human heart. And that RCD is sensitive enough to spot it every single time.
And the reaction time? It is just unbelievable. It can shut off the power in as little as 30 milliseconds. That's 0.03 seconds. It is literally faster than you can blink. And, most importantly, it's fast enough to stop an electric shock before it can cause serious injury or stop your heart.
Okay, so we've met our two heroes, the earth wire and the RCD. Now let's go back to that dangerous kettle scenario and see how these two work together as a team to save the day.
So the exact same fault happens. That frayed live wire touches the kettle's metal body. But this time, the earth wire is also connected to that body. Instantly, a huge surge of current takes that path of least resistance and rushes down the earth wire, our emergency exit. The RCD immediately sees this imbalance. All that current is missing from the neutral wire, and click, it trips. The power to the circuit is cut.
And the result of all that? By the time you even reach out to touch that kettle, the power is already off. The danger has been completely neutralized before you were ever even exposed to it. The system worked exactly as it should. Disaster averted. You're safe.
Okay, so let's just quickly recap the big points here. First, grounding isn't an optional extra. It is a life-saving necessity. Second, it provides that super safe escape route for dangerous faults. Third, it works as a team with that RCD, which is the super fast detector. And altogether, this system doesn't just protect you from a nasty shock, it also helps prevent fires by shutting things down before they can overheat.
So I'll just leave you with this thought. Every modern home has this safety system built in. It's designed to be your silent bodyguard. But if you're in an older home, or maybe if some wiring has been damaged, it might not be working right. So it's really worth making sure your bodyguard is always on duty.
Next time, we're going to get a little more technical, but it's just as important. We're going to dive into braking capacity. I'll break down exactly what that means and show you how to figure out the right KA rating for your circuit breakers.
Hey, if you found this explainer helpful, do me a favor and hit that like button, and maybe think about subscribing to Electromade Easy. We've got more clear and simple explainers on complex electrical stuff coming your way. See you in the next one.